In this video, we will talk about IB Math Past Paper, AA Higher Level, Paper 1, Time Zone 1, May 2021. First, we look at Section A, Question 1. A graph of fx is shown in the diagram. In Part A, we need to find f2. That means we need to find the y-coordinate of the graph when x is 2. So, for x is 2, the point of the graph lies here and the y-coordinate is 6. After that, we need to find ff2. As we know that f2 is 6, we can just simply substitute it into the function. So, ff2 is just f6, and we look at x equal to 6. The point is here, and the y-coordinate is -2. Done. So far, the questions are easy. And then, in Part B, it gives us another function g which is related to the previous function f. This is a question about transformation of graph. Gx is equal to half fx plus 1, so it consists of two transformations. First, we need to consider half fx. Since it is a constant multiplying fx, it is a vertical stretch with a scale factor half. That means the distance between the x-axis and all the points of the function f will be half. Distance 4 becomes 2, 6 becomes 3, 0 stays 0, and so on. After the first change, we need to add 1 to the function. That means move the line up by 1 unit, and we get the final answer. Question 2. Here is an arithmetic sequence where the 8th term and the sum of the first 8 terms are also 8. We need to find the first term and the common difference. Obviously, we need to set some equations by this. By the general formula of AS, UN is U1 plus N minus 1 times the common difference. Then we can substitute 8 for UN and N. After simplifying it, we get one equation. And then, by the general formula of arithmetic series, we have Sn equal to U1 plus Un divided by 2 times n. Of course, then we do substitution for n and Sn again. After simplification, we can get the second equation. Now, we just need to solve simultaneous equations. Use the tricks we learned from middle school. We can get D is 2 and U1 is -6. Question 3. Here is a box and whisker diagram. Lower quartile and upper quartile are unknowns, but minimum, median, and maximum is given. The interquartile range is 20 and there is no outlier. Part A. We need to find the minimum possible value of the upper quartile. As there is no outlier, the maximum 75 must not be greater than the upper bound of the data. So, upper bound is equal to the upper quartile plus 1.5 interquartile range, which must be greater than 75. After we set the inequality, we can solve it and we can get the minimum possible value of U is 45. Part B. We need to find the possible value of the lower quartile. As the interquartile range is 20, the lower quartile is just the upper quartile minus that, which is 25. Question 4. Function f is this, function g is this. And for part A, we need to find f dot x. So, we just differentiate it. For the first term, we need to use power rule, put the index number in front, and subtract it by 1. So, we get -2 bracket x minus h. Of course, by chain rule, we need to multiply it by the derivative of the things inside the bracket. Anyway, it is just 1, so no change. Then, for the second term, it is just a constant, so it disappears after differentiation. Part B. F and G have common tangent at x equals 3. This is a very common type of questions in calculus. Common tangent means that their slopes are the same at that point. So, f dot 3 is equal to g dot 3. Also, they touch at that point. So, f3 is equal to g3. We need to show h equal to something. So, we find g dot x first, and then we substitute 3 for x. As we find f dot x in part A, we can also put 3 into it. Set them equal to each other, solve it, and done. Part C. So k is equal to something. Obviously, we need to use the second equation we wrote. f3 is equal to g3. By substitution, we can get g3 and f3. Set them equal to each other. Without making calculus mistake, we find k. Question 5. Trigonometry. We need to show something are the same. For this kind of identity questions, we always start the question from the complicated side. For this question, left-hand side is more complicated, as there are 2x inside sine and cosine, but just single x on the right-hand side. We should use double angle formula to break the terms in the left-hand side. So, for sine 2x, we can change it to 2 sine x cosine x. But for cosine 2x, there are 3 ways to change it. So, which one should we use? We also need to consider the right-hand side. After we expand it, we find that the 2 sine x cosine x part are the same. And the only difference is the negative 2 sine square part. So, we better choose the way containing 2 sine square x. After replacing the cosine 2x and do some simple calculation, we can show that both sides are the same. Part B. Solving trigonometric equation. Obviously, we need to change the left-hand side thing by part A's identity. And after that, we need to have good observation. Cosine x minus sine x are the common factor for the front and the later parts, so we can factorize it. By new factor rule, cosine x is equal to sine x, and 2 sine x plus 1 is equal to 0. We can get tangent x equals 1 and sine x equals negative half. As we should remember the trigonometric value from 0 to 90 degrees. We can find the first solution. I call it solution A, and I have a tricky way to find the second solution from 0 to 2 pi. I call it solution B. Then, the 4 solutions can be found easily. Question 6. Solving trigonometric equation again. We have cosecant theta equals 3 over 2. Every time, when I see cosecant, secant, and cotangent, I will change them to be 1 over sine, 1 over cosine, and 1 over tangent first, since it would be more convenient for our calculation. So, here, we can get sine theta equals 2 over 3. Theta is between pi over 2 and 3 pi over 2, and we need to find cotangent theta. To get that, we need cosine theta as well. When we need to find sine or cosine, given that we have the other one, we need to use the identity sine square plus cosine square equals 1. Substitute 2 over 3 for sine theta, we can get cosine square theta equals 5 over 9. Then, what should be cosine theta? Normally, we just take the square root of 5 over 9 and get 2 possibilities. Positive root 5 over 3 or negative root 5 over 3. Be careful, don't forget to consider the range of theta. We need to use the CAST graph. When the range of theta is this, it would be in S or T quadrant. That means only tangent and sine theta will be positive. So, cosine theta must be negative. That means it can only be negative root 5 over 3. After that, we can calculate tangent theta, which is just sine over cosine. We get 2 over negative root 5, then cotangent theta is just the reciprocal of that, negative root 5 over 2. Question 7. A quartic equation with complex roots. There are 2 roots and we need to find the value of A. When we have a complex root of an equation, its conjugate must be the root of this equation also. So, we can get two more roots in terms of a and b. As we have all the roots of this equation, we can consider the sum and product of roots of this equation. The sum of roots must be the negative of the coefficient of the term with second large power, which is negative 4. So, we can set up an equation by adding up all the roots. After simplifying it, we get a plus b equals negative 2. Then, the product of roots must be the constant term times negative 1 to the power of the equation. That is 400. After simplifying it, we get another equation. Solving simultaneous equations with substitution of b, we finally get a equals negative 4 or 2. Question 8. We need to use L'Hospital rule to find a limit. First of all, we need to ask ourselves, when can we use L'Hospital rule? When we substitute the value of x approaching for x, we get 0 over 0 or infinite over infinite. We need to apply the rule by differentiating the numerator and the denominator. For the question here, if we do substitution, we will get 0 over 0. So, we just do differentiation for arctan 2x and tan 3x. Also, we need to remember the derivative of arctan and tan x. After substitution of 2x and 3x, we need to use chain rule as well. So, we get this expression. Now, we can try to substitute 0 for x again. Secant square 0 is just 1 over cosine square 0, which is 1. Finally, we get 2 over 3. Question 9. A farmer has 6 pens and 5 sheep, A, B, C, D, and E. A and B would fight. Part A. We need to find the number of ways of placing the sheep. Each pen is large enough to contain 5 sheep, but A and B cannot be placed in the same pen. So, I will consider this question in the following way. I put the sheep into the pens one by one. First, for A, as I can put it in any pens, there are 6 choices. Then, for sheep B, as it would fight with A, I cannot put it into the pen with A. So, there are only 5 choices. For the other sheep, they are similar to the situation of A. Without any limitation, there are 6 choices for them. We multiply the number of choices together and we get 6480. Part B. Now, each pen can only contain 1 sheep. A and B cannot be placed in pens that share a boundary. For this question, we have a lot of different ways to consider it. For me, I will also put the sheep into the pens one by one. For sheep A, there are 2 types of situations. Either we can put it into the corners or put it in the middle pens. If we place it in the corner, there are 4 choices. Then, there are only 3 choices for placing B. I use yellow circles to mark it. It's because we cannot place B into the pen that sharing the boundary of the pen with A or into the pen containing A. After placing A and B, there are only 4 pens left for C. And after placing C, just 3 choices for D and 2 for E. We multiply all choices together and get 288. After that, we consider the other situation, placing A in the middle pens. There are 2 choices for A, and then only 2 choices for B, which I use yellow circle to present it. Then only 4 pens left for C, and which is similar to the previous case. Finally, we multiply all the choices together and we get 96 ways. Then we add this to the first situation and get 384 ways in total. Question 10. Here is a probability distribution table for X. Part A, we need to find P. As the probability of all the situations add together must be 1, we can simply make the equation and get P equals 2 over 7. Part B. We need to find the expected value of x. That means we need to add all the values multiplying their own probability together. So, we get 8p, which is 16 over 7. Part C. We need to find R. As probability of any situation or all the situations must be between 0 and 1, so does R. Similarly, we have VQ between 0 and 1, and thus Q is between 0 and 1/3. Part D, we want to find the expected value of Y. Similar to Part B, we add all the values multiplying their own probability together, and we get 6Q plus 4R. Then we stuck, since there is no way for us to tell the range of EY. What should we do? Here is always the trick of probability question in IB. As what I mentioned in Part A, add the probability of all the situations together must be 1. We have VQ plus R equal to 1. So, now we can make R in terms of Q and substitute it back to EY. Finally, we have EY equals 4 minus 6Q. As we know, Q is between 0 and 1/3. So, we substitute 0 for Q. We can get the upper bound 4, and we substitute 1/3 for Q. We get the lower bound 2. For question E, we need to find the expected value of Y. It is a very tricky question. The probability of A is less than B by half, so we need to make an equation by this sentence. We look at the tables above. What are the situations that A score is less than B score? A gets 1 and B gets 2, 3, 4, or A gets 2 and B gets 3, 4, or A gets 3 and B gets 4. So, in total, there are 6 situations. We need to list these 6 cases and try to add the probability of them together. For example, A gets 1 score, the probability is P. For B gets 2, 3, 4, the probability is 2P plus R. Then, we multiply them, and we consider the other situations as well. Finally, we get P times 3Q plus 3R. As we know, P is 2 over 7, and R is 1 minus 3Q. Finally, we can get 6 over 7 times 1 minus 2Q. This is the expression for the probability that A score is less than B score. And by the sentence above, we know that it is equal to half. So, we set it to be half, and we get our equation. Solve it, and we get Q equals 5 over 24. So, we can substitute it back to the expected value of Y we find in Part D. After tons of work, we get 11 over 4. Question 11. A line with Cartesian equation is given. Part A. We need to show that this point lies on L. So easy, we just do substitution. And then, we need to find a vector equation of L1. That means, we need to write x, y, and z in terms of the same parameter, which I call it lambda. So, we just let lambda to be the same as the previous expressions, and rearrange them. Finally, we can change it to a vector equation. Part B. We have another line L2, which is defined by the following. And we need to find A if the angle between L1 and L2 is 45 degrees. When it is related to the angles between two lines, we should apply the equation of A dot B equals to the product of their norms times cosine theta. Consider their dot product. Find the lengths of A and B, substitute 45 for theta, and then, after some calculation, it becomes a quadratic equation. As it cannot be easily factorized, we just apply quadratic formula and get the two solutions for A. Part C. L1 and L2 have a unique intersection if A is not equal to K. Now, we want to find K and the coordinates of capital letter A in terms of small letter a. As we want to find K, we try to consider the opposite way, making A to be K. So, we said there is no intersection for L1 and L2. That means L1 is parallel to L2. Then, their divergent vector will be with the same ratio. For here, as the y and z entries are the same, A must be 2, as well as K. After that, we try to find the intersection of L1 and L2. So, we set them to be the same. We get 3 equations. Since our final answers will be in terms of small letter a, we try to make t to be the subject by eliminating lambda. We check the redundant equation and we get t equals 1 over a minus 2. By substituting back to the vector equation of L2, we get the final answer. Question 12. The final question. Part A. A function f is this, and we need to find its second derivative. So, we just do 2 times differentiation on that. By power rule and train rule, the answer can be found. Part B. We need to use mathematical induction to prove the following statement. I just call the statement Pn, where n is any integer greater than or equal to 2. Actually, we have already proved the case for n equals 2 in part A. Now, we just need to assume the statement is true for n equals k and prove that it is true for k plus 1 also. Anyway, I just copy the statement here for later use. Now, we start from left-hand side of the statement for n equals k plus 1. That is equivalent to find the derivative of the upper expression of fkx. As this part is constant, we just need to copy and differentiate the later part. By power rule, we get this. Then, we try to see our target by consider the right-hand side as well. So, after simplification, we get the expression of our target. We try to check the common things for the 2 expressions. We can see that they also contain negative 1/4 power term. But one is with power k and the other is with power k minus 1. Multiply the left-hand side by negative 1/4. Both sides are the same now. And then, we need to multiply negative 4 for balancing. Copy the rest and do some simplification. Now, this term and this term are the same. So, I use a purple box to contain it. And the only different part is the middle one. We try to simplify the terms. Multiplying these terms to eliminate the fraction inside the bracket. The denominator of the left-hand side is k minus 2 factorial, but just k minus 1 factorial on right-hand side. So, we multiply it by k minus 1 over k minus 1. And then, we just do some calculation for the numerator. They become the same. So, by MI principle, the statement is true for all n greater than or equal to 2. Final part. Part C. We have a function g, and there is another function h, which is f times g. Given that x squared term of the Maclaurin series for h has a coefficient of 7 over 4, we need to find m. So, we just try to find the Maclaurin series of f and g first. As we just need the x squared term, we find fo, f dot o, and f dot dot o. Of course, we need to do the same for g as well. Finally, by the formula of Maclaurin series, we have these 2 expressions for f and g. And then, we can get h by multiplying them together. As we just need to consider x squared term, we multiply this with this with this, and this with this. Finally, we get this. Then, we just set the coefficient to be 7 over 4. After simplification, we get a quadratic equation. By factorization, we get m equals 3 over 2 or negative 5 over 2. Done. We have gone through all the questions in this paper already. Thank you for watching. If you like it or want to know more, please like and subscribe my channel. Bye bye.